this, we talked about what is light. And so we talked about how you can break everything into parts. So the parts you can break stuff into were what?
Particles and waves.
Particles and waves, very nice. And we talked yesterday all about how light was what?
A wave.
A wave.
But today we are talking how it's a particle.
Exactly, but before we get to that,
I get money.
Brianna, before I forget, my wife keeps texting me and blowing me up about it. So in this, we talked about how light's a wave. How is light proved to be a wave? Okay, by Thomas Young's double slit experiment. So in that, why could we deduce that light was a wave?
The interference pattern.
The interference pattern that came on the back screen. Okay? How do we get interference patterns?
It has a dark spot. Light sources.
Basically just a lot.
Yeah, the light spots, the dark spots, but how? What's happening?
That's the only thing I got from that.
Light naturally
And
does
that the
that.
guy can actually.
What is it? When a crest meets a trough, when crest meets a trough, what do we see?
Cancels out.
Cancels
Dark
out,
spot.
so there's
Dark spot.
nothing. Okay, we see the dark fringes.
Yeah.
What do we see if a crest meets a crest?
The light part.
We see the light. We see the bright fringes. What about when a trough meets a trough?
Well,
Cancels out, don't it?
remember if we can.
I don't think we went over that. Yes, we did. We did.
When trough meets trough, are they the same part of the wave?
Yeah.
So will it cancel them out?
No.
No. Oh.
So it does the same thing as the crest in a crest. That's where you would see the fringes. Now, just so you're aware, this applies like on that wave. Like you can look and see if they're canceling each other out. If they're on opposing sides, then yes. But we keep it very simplistic in here just as an understanding. So if a crest and a trough meet, or a trough and a crest meet, dark fringe. If crest and crest meet, we get the bright fringe. If the trough and trough meet, we get a bright, we see the light, we see the bright fringe. Okay? Or any question with Thomas Young's double slit experiment? Nothing?
Learn it, don't forget it. Always forget it.
Yes. Thomas Young did not say that. Kevin Hall said that. So today,
We're learning about Thomas Edison.
Kevin DeWeedy.
What proof equal light?
sound like you've been talking to my sister. We're talking about a particle. You've heard these terminologies before. Now you're going to really get introduced really with them. So in this, I want to talk about light being a particle. Okay? What? I got to remember how I jacked English up yesterday.
What proof light equal wave? Yeah. Question mark,
Okay,
question
what
mark.
proof? Well, let's put a capital F just to really mess it up.
I've got it hurts.
Light equal particle.
Oh,
Oh my god, I feel like I'm supposed to be an me on the internet
Trying to
get
call
me
it
to send
from
fake
you.
pictures.
Oh, God. Yesterday, I
What proof light equal particles?
What light equal particle?
Hey, how much of that?
No.
It's like the Stonehenge off of the Knights Museum. Gum gum. What my gum gum?
Did you say Stonehenge?
I said Stonehead.
Oh,
Yeah,
well,
you
you said
said
Stonehenge. I went, no. Wrong one. Easter one.
All right. So in this, what proof light equal particle? Okay. I can see it. It's like I love to scan the room and see the faces. It's like, oh! And then they'll say it, they like cringe.
Greatness.
English people. You can send this video to Miss Steffi later on.
I want to take a picture of her so bad.
Go right ahead.
Honestly.
So in this, what proof is this? So who proved this is the first question. And you know this person. You absolutely know this person. I said this is not even fifth period yesterday too, and nobody could guess who it was.
Albert Einstein. We said that yesterday.
When I put AL down, I didn't hear it.
We said it yesterday.
Oh.
Albert Einstein.
Tiffany Copley, come to the office.
I think it's.
E equals mc squared, blah, 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 blah.
I think that's
the
right.
rest of the
Einstein may
equation.
not be right, but you get the
That
premise.
Equals MC squared, rest of the equation, I don't know, because you're gonna yell at me for just saying equals MC squared.
It's because everybody forgets about the.
Mariah Carey's album's fucking MC squared.
In this, here's the really cool thing. Do you know why Albert Einstein? What did Albert Einstein get his Nobel Prize for?
Lower theory of relativity, maybe. I don't know.
No,
Speed of light.
no,
They discovered light.
no.
Energy.
But you're really close.
He
discovered-
He made his own form of light. Made
No.
his own
No.
No, that's
He-
Thomas Edison.
He
radioactive.
Albert Einstein's photon.
photosynthesis.
Photoelectric.
Photoelectric.
Yeah, there you go, bud. So Albert Einstein, in 1905, he released 3 monumental papers for the scientific community. Albert Einstein was single-handedly responsible for ripping physics straight to shreds. They've spent all this time from Isaac Newton to the 1900s of building up all the knowledge that we had of physics. And it was kind of like a wall that everything was there with only a couple cracks that we had to fill. Well, Albert Einstein comes in at that little crack and says, boys, y'all got this all wrong, and just tears the whole wall down. Which is why no one wanted to listen to him. Which is why it took him forever to get to this. But this right here is what he won the Nobel Prize for. And this is why. The photoelectric effect proves light is a particle.
Whoa!
In this is how it works. Hopefully none of you in here have seen this before. In person, you've probably watched a video of it. Let's say I have a piece of metal on there. Now something you're going to learn later on is with metals. To form a metallic bond, what happens is they just give up electrons freely and they form this sea of electrons. That's what gives all metals all the properties. But this is the thing. Let's say on this piece of metal I have, and let's do aluminum.
That's what.
So aluminum metal. This is what the photoelectric effect talks about. What Albert Einstein did is he took a piece of metal and he threw, and well, he shined light on it. And this is the interesting thing. So this is kind of like how he started off. So let's say he starts with red light, and he fired it at that sheet of metal. Nothing happened. Then from here he said, well, I wonder what will happen if we kick it up the spectrum a little bit. So he takes it.
Mr. Hall,
Yes.
you have Jesse Lister?
Who?
Jesse Lister?
I do not.
Okay, thank you.
So from here, red light comes in, no effect. So he decides to kick this up a little bit. Okay? Now, I don't know exactly how he went through this, but let's just say that Albert Einstein, this is the premise of what he did. He decides to jump in there and says, well, if red light ain't going to do it, let's see what'll happen if I throw a stinking X-ray at that thing.
I was thinking more so cameras.
stinking X-ray.
So he goes in there
Mr.
and he
Ohio.
fires this X-ray on here, and something interesting takes place. When he did that,
It caught fire.
new fire did not happen,
Oh.
Did it go through?
It bounced.
and an electron pops off.
Wow.
Oh my God, please don't.
Papa, power nose.
Now within this is the key to this. An electron popped off.
Uh-huh.
What are electrons?
Yeah, it's negative.
Y'all have like mixed ideas with half of it being right and half of it like through the mumbling and everything.
Oh, it's a
Is that-
particle.
Particle.
It's a, okay, a particle, yes, but we like to call it a subatomic particle.
I'm dead.
You are smart. You're in this class, ain't you?
I am forced to be.
Very nice. It's probably what keeps me having 2 chemistry classes.
Probably.
All right, in this, a subatomic particle, okay, if you want to be technical, you can say negatively charged subatomic particle, but the thing we're caring about right here, right now, is a subatomic particle. So think. What is X-rays? Particles or waves?
A wave.
These are waves. So we thought.
Wait, huh?
What?
Whoa. Dun, dun, dun.
Just think. If I want to move my coffee cup,
Yes.
what do I have to do to move it? I have to pick it up. But if I pick it up, what's grabbing it? What would you label my hand to be? Particle or wave?
Particle.
Particle. So if I want this cup to move, I have got to use another particle to move it. I can shoot waves at it all day long. It won't
Or
move.
so you thought.
The wave theory of light can explain this. You can explain taking a wave, firing it at particles, and particles shooting off. In this, it led to one conclusion. Electromagnetic
Light.
radiation,
Radiation.
because what's on the electromagnetic spectrum?
Radiation.
Electromagnetic radiation. Electromagnetic radiation is a particle.
Whoa! That's fun.
So question.
But wait,
But hold up.
But wait, there's more.
oh my God! As proved, let's do prove it. Let's not
Oh
kill
my
y'all.
God.
All student council members that are going to Rice Branch, please report
As
to the office.
proven,
All student council members
By-
that are going to Rice Branch, please report to the office.
the photoelectric effect.
So question. Is like the visible light spectrum particles too?
Is it electromagnetic radiation?
Yeah, I guess.
This is the thing, and this is why I really start like getting into this, because it starts frying people's brains.
Literally.
That's
Number
proven
one.
by the photoelectric effect. But there's more.
Stop it. No.
This proved that light or electromagnetic radiation was a particle. But in 1801, Thomas Young did an experiment to prove that light was a wave.
So what is it?
It's both.
So,
Wait, can
It's,
something be both a light and Or
Polar wave.
It
Cave.
also is a wave.
It's a word.
It's a vertical.
It's a word.
As proven by
Thomas Young.
the double slit experiment.
Mr. Hall, can we go back to the mall map?
I don't know. We can have it.
We shall, but later on.
Yeah, it looks like compliment.
Here's the key in this, okay? You need to understand what you're dealing with. So first, we have proof that electromagnetic radiation is a particle and a wave. Now here's the key to this. Within the photoelectric effect, before I move on to breaking that down anymore, I want to move on to the photoelectric effect. Make sure you really have understanding of what you're talking about. What did the photoelectric effect do?
It proved that light was a particle.
Proved light equal particle.
Stop.
In this is the key to the photoelectric effect. This is like the breakdown of what Albert Einstein had found out.
That was
That was me.
together.
Yeah.
Mr. Hall, I have a quick question.
Yeah.
Would anybody ever come to move our test to Monday?
No.
It's
I did
Halloween.
not knock or throw my voice like that. That is interesting.
It's Halloween.
We're in
I
high
don't care.
school.
Listen, if you want to go out, do something, have fun. You got a quiz tomorrow.
Yep.
And the lab reports are due tomorrow.
Yep.
Oh my God.
Those were set. That I've said that from
Yep.
forever.
Speaking of which, I gotta print that out one for you.
That's fine. Okay. It proved light was a particle, but this was the key of what really was found out in it. The intensity. And remember, whenever I'm writing this stuff down, I'm trying to write it in a simplistic way to where it actually makes sense to you, and y'all don't look and say, wow, Mr. Hoffman used a bunch of fancy science words. He's so smart. Who cares about that?
Mr.
I
Hall,
care
the
about that.
genius.
The intensity of the light, or let's do of the radiation, does not matter.
Mr. Hall's using big words.
The amount of energy is what matters. So it still matters. And all this is saying is you can throw, well, you can shine a red light really bright on a metal. And the electrons may not fire off. However, just makes me feel like my English is just so good when I jump in there and go, however.
It's a good transition one.
It's the only one I have.
Therefore,
I use however. Freaky sure there.
furthermore,
Okay, English people, hush. I'll tell Miss Steffi later on that she's doing a fantastic and wonderful job with you. However, you can shine ultraviolet, or I'm just going to say UV, rays, very dim, on a metal, and electrons will fire off. I want to make sure I'm clear whenever I'm saying this. On a metal, that's like a very basic term. It depends on the metal. Okay? Aluminum will have electrons fire off if you shine a certain electromagnetic radiation on it. But if you break it down and you go to gold, then gold could use a different type. Now, what I'm getting ready to say to you, because I'm going to give you proof of this, that you've seen this. So help me, this is recording right now. Parents, I am not giving your child permission to go home and do this. If they do this, they are acting on their own behalf and not because I said to do it. I'm just using it as an example, and if they want to, they can slide off this video and YouTube this happening.
Put a grape in a microwave.
No. How many of you have ever put a piece of metal in the microwave and
Don't
turned it on?
do that either.
How many of you seen the sparks firing off of it?
you ever put a jar of Nutella in the microwave?
No.
Nope.
I
But I
did.
can imagine that it might.
It
actually-
literally caught fire.
Very nice.
Why
So all of you that raised your hands, raise your hands again so I can get your names down. Does your parents know that you did this?
Oh, I did. Oh,
All right.
Might have fried
The sparks that you seen firing off, all that came off, why was it happening?
Oh my goodness.
Because
Photoelectric effect. What was happening with the metal? You have electrons
firing on.
rolling off of it.
Wait, I have
Mr. Hall, I have done this
a
before.
question.
Yeah?
Ruined the microwave and
It says
everything.
the intensity of the radiation don't matter.
Yeah.
But the amount of energy will matter. I thought like, as the radiation was greater, so was the energy.
As you move on, it does. What I'm saying when I'm saying the intensity of the radiation is like you choose the type of radiation. So let's say I take radio waves, electromagnetic radiation, radio waves, and I fire it out. I can stick it right next to a tower that's transmitting radio waves, and electrons won't fly off that thing. But then let's say I go in to somewhere where they got gamma rays, and I step out of the room because I don't want gamma rays hitting me, because remember those are harmful and could cause cancer and kill me. So be wise. And I fire gamma rays at the piece of metal. Electrons fire off. It doesn't matter if it's a very, very small source. It can throw electrons. It depends all about what metal you're dealing with. That's what's important.
I saw this one thing where this guy took like a walkie-talkie, and you know those Ring doorbells?
Mhm.
He set it to like some sort of frequency on the Hertz scale, and it like disabled everybody's security system like that in his area. Like in his neighborhood.
That's
I'd
interesting.
have to show you the video because he even like, when he bought one himself and used it, and if you turn, I think it was like 44 or something, and he turned it on, and then he was able to like open their doors and everything. And they were sitting there freaking out.
Hudson came back.
Nobody in West
And it
Virginia can
broke
afford
as
a Ring
Brandon went to
doorbell.
swing, and when he did, completely freaking missed it.
All right, so here's the key with this. You've heard this term before. So from this photoelectric effect, it has given us proof that light is a particle. So of course, you know, we can't just leave it at that.
Right.
So we got to have something to go with that. What's this particle called? Anybody want to take a shot?
Photon?
A photon. And here's the thing with a photon. All it is a particle of electromagnetic radiation. That has a quanta certain value. Quanta. I have to use quanta for a reason because you're getting ready to start. I just gotta use quanta. I don't want to. Everybody make crap.
Quanta.
Has a quanta of energy.
I'm saying no. Quanta.
Are we going to learn what that is?
No.
Quanta is just a certain amount.
So like quantity.
Yeah, pretty much.
Why can't we use the quantity?
Because that's
Because it has to be quanta. It's not called quantity mechanics. It's called quantum mechanics. You're going to learn the premise, the base, and foundation for all things quantum.
Are we quantum?
On a technicality, yeah. It has a quanta of energy and no mass.
Wait, I thought everything had a mass.
Never mind. No. Just the X bad. It was it.
So here's the important aspects of it. Okay? What light is a particle?
The photoelectro effect.
Photoelectric effect. Who was the scientist that proved light was a particle?
Albert Einstein.
Albert Einstein. Does intensity matter for the photoelectric effect?
No.
What matters in terms of the photoelectric effect?
The amount of energy.
The amount of energy of that photon. Okay? The amount of energy for that photon. What proved the light was a wave.
The double slit experiment.
Double slit experiment.
Thomas Young.
Who proved it? Thomas Young. Which brings me to a beautiful idea.
No more ideas.
Oh yeah.
We have-
This
Yeah.
literally wrecks the world of physics and opens it up for everything. Why? Because at this time, you could not have something to be a wave and to be a particle. You just can't have it. It was either a wave or a particle. It can't be both till now. You can't argue with an experiment that proves light was a wave, and you can't argue with an experiment that proves light was a particle. So what do physicists and chemists decide? By Georgie, they're both. Which brings us to wave particle duality.
Wow.
Wave particle duality states that electromagnetic radiation exists as both waves and particles. I got time to get it in.
Yes.
You can do it. I believe in you.
So in this, it brings us into a realm of something interesting. How many of you have seen models of atoms that we use?
Yeah. Sure. Okay. Yeah. Yeah. Yeah.
How many of you have seen this before?
Yeah.
With electrons placed on them. That's good, okay? There's hope for America yet.
William Ford, right?
Now in this, do you know what these circles stand for?
Electron fields.
The solar system.
No.
Flame.
No. No. The circles are energy levels. And here's the important aspect when you're talking about energy levels. This is crucial. How many of you like SpongeBob in here?
Nope.
The only way I know how to explain this to you is the salty spittoon. These are like different levels of the salty spittoon. How can you get into the salty spittoon?
Man, a little bad.
You gotta be tough. So it's kind of like here in the first energy level, you gotta be tough. You gotta be able to twist the lid off of a bottle of ketchup.
No. Grape jelly. You can't get the lid off the jelly jar.
Oh my
Okay.
gosh.
The second level of the salty spittoon, you gotta have muscles on your muscles. And if you want to get to the third level of the salty spittoon, you gotta have muscles on your eyeballs.
You got nails.
In terms of atomic level, what I'm saying is you can't get to the first energy level unless you have enough energy to get to the first energy level.
And the middle is getting a bowl of nails with no milk.
No, that's the seventh level. That's close though. The second level, you can only get to the second energy level if you have enough energy to get to that level. You can't get here
You can't.
if you don't have enough energy to get there. So just to place this in terms that you'll relate with, what I'm going to say to you is not scientifically true, but it's in terms that you can understand what's going on here. Let's say here at the first energy level, I
Maddie Cook, report to the office, Maddie Cook.
have to have 10 joules of energy to be able to be there. Now let's say at the second energy level, I have to have 25 joules of energy to get there. Now let's say at the third energy level, I have to have 32 joules of energy to get there. Now the equivalent of every one of these, you can find within your standard classroom. It doesn't even have to be a science one. Seth, if I fall and die, tell my wife I love her.
Fair enough.
In this,
Don't you dare step on that roll.
here's the first energy level.
Don't do it, please. Oh, Mr. Hall.
Yeah! There we go.
We got this on video.
That's why you do the road trade. You pop up and down. The only problem is getting to the second energy. Now this is the thing. I got 10 joules of energy. I'm here. I'm good to go.
Do you need help?
I do not. Maybe. Now if I have, what do I have to get to the second energy level?
25.
If I have 24 joules of energy,
You ain't done.
I can get to here. Can I get to the second energy level?
No.
I'm stuck in the first. But by George's, if I get 25, what can I do?
Get up there.
Jump.
This is energy
That's
level
not
number
go.
3.
So, here we are.
Mr.
these days for them to walk in during this moment and say, what is going on? And I'm going to say science.
He just played
All right, second energy level. If I want to get to the third energy level, what do I got to have?
32.
32 joules. Then I can get up here.
Whoa. He had 32.
Scream like Godzilla.
I can't scream like Godzilla. All right, listen. This is the point. This is it. This is your quiz. Okay? This is ends. This is everything that you've gotten.
Okay.
Study. If you have questions, message me. I will send out answer keys later on and reminds. Y'all have a fantastic, wonderful day. And chemistry is exciting from here, people.